When we want to carry out a significance test for a proportion, there are three conditions that must always be met. Actually, they are the same conditions that we had to meet when we were doing confidence intervals. So, they're actually the same. So, the first one of those, if you remember, is random. Okay, and to achieve the random condition, it must say that it's random in the problem. Okay, the second one is normal. Okay, remember that in a confidence interval, the only thing we have to go off of is p-hat. Here in a statistical test, we are using the null and assuming that the null is the mean of our sampling distribution. And we're going to call the null value p sub 0. Okay? That means that in these normal conditions, we need to use the null because that's what we're assuming is true. So that is the one difference between confidence intervals and significance tests, is that in significance tests, when you check the condition, you need to assume the null value is true. The third one, independent. Okay, same thing. The 10% condition still applies for independence. So your sample needs to be less than 1/10 of your population. Okay, once we check our conditions, then we look at our do step. And our do step is where we calculate what we call a test statistic. Okay, here's the test statistic formula. What the test statistic is, it's a statistic, which is the information we get from our sample, minus our parameter, which is the information we get from our null, divided by the standard deviation of the statistic. Okay, the formula for the test statistic appears on the AP formula sheet just like this. Okay, this is what you will see on the formula sheet. Okay, they are expecting you to know how to change the values. For example, they're expecting you to say statistic. Okay, for us right now, that's going to be a p-hat. Parameter, that's the value that we're pretending is the mean, so that's the null. And then the standard deviation of the statistic is the standard deviation of p-hat. Okay, again, since I have a value that I'm pretending to be the null, that's the value I use when calculating this, or pretending to be the actual mean. So, this right here, p-hat minus p sub 0 over the standard deviation of p-hat, that would be my test statistic. And because I'm dealing with p, I use z just like I used it with confidence intervals. So let's look at this example as we revisit Jack's campaign for mayor that we looked at in our activity we did a few weeks ago. So he needs, and it really should probably say at least 50% or more than 50% of the votes in order to win the election. In an SRS of 100 voters, 56 favored Jack. So we need to check out these conditions to make sure that we can use a significance test. Remember that the first condition is random. And it does say that it's random because it says that it's an SRS. Okay, number 2 would be normal. Okay, for normal we don't use p-hat. P-hat's this 56 out of 100. Okay, that's going to be p-hat. We don't use p-hat, we use p, which is this right here, the null. So we would say 100 times 0.5 is greater than or equal to 10. And if I say 1 minus 0.5, it's going to be 0.5, so I just have to redo that. Okay, number 3. Independent. And we need to assume that at least 1,000 people are voting, which is not a bad assumption. So we can do that. So we can assume there are at least 1,000 voters. Okay, so then when I calculate the test statistic, remember that's Z is equal to P hat, which would be 0.56, minus the 0.5 divided by, and then I need to say 0.5 times 1 minus 0.5, which is just 0.5, over 100, and then take the square root of that. And that gives us a test statistic of 1.2. Okay, so what this test statistic tells us is that this P hat is 1.2 standard deviations away and above what we feel like the null is. So if this were our null here, our 0.5, our P hat of 0.56 would be somewhere around in here. And this distance right here would be our Z statistic. How many standard deviations away from what we assume to be the mean is our P hat. So then we look at this p-value, and when we're interpreting the p-value, that's what we're, well, first we have to calculate the p-value. And to calculate the p-value, we basically, it works just like a normal curve. So what I'm looking for is if this is 0.5, which is in the standard normal curve mean of 0, then 0.56, which has a standard deviation of 1.2, would be here. And so I'm saying, what is the probability that I'm going to get a z-score greater than or equal to 1.2? Okay, I can use normal CDF to figure that out on my calculator. Remember, that's in the distributions menu. And I can actually just type in my z-score boundaries. So 1.2, and then because I want everything bigger than that, I just pick some really big number. And what that gives me is a p-value of 0.1151. So then to interpret that, I say this. If my null is true, which means exactly 50% of voters support Jack, then there is about a 11.5% chance that 56 or more voters would favor Jack in a sample of 100. Okay, so if exactly 50% of voters favor Jack, then there is about a 11.5% chance that 56% or more voters would favor Jack in a sample size of 100. That's how we interpret p-values. Okay, so as always, we have 4 steps for conducting our significance test. The first step is state. And when we're working with state, we want to state the alpha value. We want to state the hypotheses. And we want to define any parameters. So if I'm working with P, I want to say what I'm finding the proportion of. If I'm working with mean, I want to say what I'm finding the mean of. Make sure you define your parameters. Okay? 2, plan. I want to state the method. Okay? With the confidence intervals, it was okay to state the formula, but there is no real formula for this, so you got to know the names of these. Okay, the name for the one that we're doing right now for proportions is this 1's apple t-test for a proportion. Okay, you also want to check your conditions. 3 is your do. Okay, the do step which tells us that's when we need to do our test statistic. And our p-value. And then we need to conclude, which means we need to interpret in context. Okay, so we've already talked about which test statistic is used, and remember that is Z. And we've talked about the fact that it's not on the formula sheet. Okay, only the words. So one thing that we do need to talk about here is this shortcut. I know that everybody likes a shortcut. So one thing you can do to see if there's a shortcut is look and make sure that your data supports your alternative hypothesis. So for example, let's say that we have a null where p is equal to 0.5 and an alternative where p is greater than 0.5. And we actually calculate our p-hat and we get 0.3. Okay, this goes against our alternative hypothesis here because this is actually less than 0.5. So since our p-hat, our only piece of evidence that we have, goes against what we're trying to prove, I know that I'm going to end up failing to reject. So I can just say that I'm going to fail to reject because my sample data does not support my alternative hypothesis. So on shows like American Idol, contestants often wonder if there's an advantage to performing last. To investigate this, a random sample of 600 American Idol fans is selected, and they are shown the audition tapes of 12 never-before-seen contestants. For each fan, the order of the 12 videos is randomly determined. Thus, if the order of performance doesn't matter, we would expect approximately 1/12 of the fans to prefer the last contestant they view. In this study, 59 of the 600 fans preferred the last contestant they viewed. So does this provide convincing evidence that there is an advantage to going last? So, first thing we need to look at is the hypotheses and the state. They don't give us an alpha level, so we need an alpha level of 0.05. And my hypothesis is I'm going to assume there's no advantage. So that would be a proportion equal to 1/12. And my alternative is if I assume there is an advantage, my proportion is going to be greater than 1/12. And I need to say that P is the true proportion of fans who vote for the last contestant. Okay, I need to state my method, which is a one sample z-test for P, and I need to check all of my conditions. And I'm not going to write them down, but you want to make sure that you check them. Random, okay, it's important that it says both they took a random sample and they randomly picked the order. So you would need to say that both the sample and the order were random. 2 would be normal. Okay, 600 times 1/12 is 50. That's greater than 10. And 600 times 11/12 is 550. That's also greater than or equal to 10. Okay, finally, independent. Okay, we can assume that there are at least 6,000 people who watch American Idol. So once I've done my state and my conditions are checked, then I can do my my Z statistic. So Z is equal to the p-hat, which is 59 out of 600, minus the 1/12, divided by the square root, and I want to use p hat, so that's 1/12 times 11/12 over 600. So that gives us a p-value of z value of 1.33, which then I plug into my computer, and I get a p-value of 0.0918. Okay, so then I have to say this, that because p-value is greater than alpha, we fail to reject the null hypothesis. There is not convincing evidence that going last is an advantage on idle. Okay, make sure you remember that whenever we fail to reject, that's when we say there is not convincing evidence. If we reject, that means there is convincing evidence. But when p-value is greater than alpha, we fail to reject, so there's not convincing evidence. The last thing that we have to talk about today are two-sided tests. So what do you do if you don't have any way of being able to decipher which direction your alternative should go, and you need to use a two-sided test which is not equal to? Okay, so in this case, AJL and Associates audits a company's financial records for fraud. They use a test based on Benford's law. Benford's law states that the distribution of first digits in many real-life sources of data is not uniform. In fact, when there's no fraud, about 30.1% of numbers in financial records begin with the digit 1. However, if the proportion of first digits that are 1 is significantly different from 0.301 in a random sample of records, the firm does a much more thorough investigation of the company. So let's say that we have a random sample of 300 expenses from a company's financial records, and only 68 begin with the digit 1. Should AJL and Associates do a more thorough investigation? So in this case, again, they don't give us an alpha level, so we're going to say alpha is equal to 0.05. My null would be, let's assume that there is no fraud, so that would be P should be equal to about 0.301. My alternative, since it just says different, is P is not equal to 0.301. Okay? And P is the proportion of records that begin with the digit 1. So we're going to, bypass the conditions. I'm going to tell you that all the conditions are met. And we're going to go straight to how this is different. Okay, this is the only way this is different. If this is a two-sided test, I'm going to calculate the z like normal. So 68 out of 300 minus 0.301 over 0.301 times 0.699 over 300. And that gives me a z-score, or a z-statistic, of negative 2.79. Okay, when I am looking at this, if it's a two-sided test, then my 0.05 has to be split on both edges. So it's a total of 5% between this part and this part. So when I find my z-score here, I'm only going to be able to find the probability that z is less than negative 2.79. But I know that because my normal curve, my sampling distribution, is symmetric and unimodal, okay, because it's normal, that these right here are the same areas. So it's going to be the same area if I say less than negative 2.79 as if I say greater than 2.79. So what I need to do here to find all of the area is multiply this by 2. So when I find it, okay, and when I find it, it ends up being 0.0026, but I need to multiply that by 2, so I actually get 0.0052. Okay, since that is less than alpha, we reject the null and say that there is convincing evidence that the proportion of expenses that have a first digit of 1 is not 0.301. As a result, the company, AJL and Associates, should do a more thorough investigation.